So here's the next problem on solving problems on quadratic forms. Good. So to solve this, there are two ways we are going to solve this one. Solution. Now we are given that quadratic form of three variables x1, x2, x3 is given by x1 squared plus 4 x2 squared plus 6 x3 squared plus 2 x1 x2 plus x2 x3 plus 3 x1 x3. Now this is how we make our life easier. We can draw this table. Say this x1, x2, x3, x1, x2, x3. x1 times x1 is x1 squared. x1 times x2 is x1, x2. x1, x3 is x1, x3. x2, x1 is x2, x1. x2, x2 is x2 squared. x2, x3 is x2, x3. And then x3, x1, x3, x2, and x3 times x3 is x3 squared. And then we go to the problem. x1 squared, the coefficient is 1, so we write here 1. x2 squared, so we write here 4. x3 squared, we write here 6. And then x2, x1, x2, so the order is 1, 2, so we write here 2. 2, 3, so 2, 3 is here, we write 1. 1, 3, so 1, 3 is here, we write 3. This remaining position, we put zeros, put 0 here, put 0 here. So that now our A matrix, which has 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, 3, 1, 3, 2, 3, 3 will be A1, 1. So just pick the numbers 1, 2, 3, 0, 4, 1, 0, 0, 6. So that is the matrix A. But this is not a symmetric matrix. Remember, the problem was asking on find a real symmetric matrix. So the thing is that we have to have a symmetric matrix. So the key term here is symmetric, not just any matrix. So if you stop here, then you have not answered the question correctly. What we do next, we know that from our study on symmetric matrices, we know that any square matrix can be expressed from this one here, actually any symmetric, any quadratic form, any quadratic form can be expressed as or in matrix form with a symmetric matrix C given by C is the average of what you have done here, A, then you add to the transpose of that matrix. So we have A is 1, 2, 3, 0, 4, 1, and then 0, 0, 6. So this implies that A transpose is given by 1, 2, 3, 0, 4, 1, 0, 0, 6. So symmetric matrix C will be given by a half of the sum of these two matrices. So we have 1 plus 1, 2 plus 0, 3 plus 0, 0 plus 2, 4 plus 4, 1 plus 0, 0 plus 3, 0 plus 1, and then 6 plus 6, which will be a half, and then 2, 2, 3, 2, 8, 1, 3, 1, and then 12. So you multiply every element by a half. So therefore, C will be 1. So a half times 2 is 1. And then half of 2 is 1. So 3 over 2, 1, 4, a half, 3 over 2, a half, and then 6. So this is the required symmetric matrix. Now, alternatively, so this is the final solution to that problem. Or if you don't want to do it in that way, you can hammer it in one way by saying you write this usual table x1, x2, x3, and then we have x1, x1, x2, x3. So here we have x1 squared, x1, x2, x1, x3, x2, x1, x2 squared, x2, x3, x3, x1, x3, x2, x3, x3 squared. Now, so remember the quadratic form was x1 squared plus 4x2 squared plus 4 plus 6x3 squared plus 2 x1 x2 plus x3 x2 x3 plus 3 x1 x3. So once you have the quadratic form and you write this table, you check x1 in this equation coefficient is 1, so you write here 1. x2 coefficient is 4, x2 squared, you write here 4. x3 squared coefficient is 6, so we write here 6. So the diagonal elements in your matrix will be 1, 4, 6. Now you come here. This is 2x1, x2. Remember in this table we have terms x1, x2, and x2, x1. Remember this product is the same term. So what you do to get the coefficient here and here, you simply take the coefficient you have here, and then you say x1, x2 plus x2, x1 is the same as 2. And these two are the same, have the same value. So 2x1, x2 is the same as 2. So which means x1, x2 is 1, which is the same as x2, x1. So simply divide this one into 2 and then share 1 here, and then another one in this position. x1, x3, x3, x1 is the same thing. So coefficient of x3, x1 is 3. So each of them will be shared equally, 3 over 2. This is 3 over 2. Coefficient of x2, x3 is 1. x2, x3 and x3, x2, they're the same products. So you simply half will be taken by this, half will be taken by this, so that we have a half plus half to get a full 1. So therefore, the symmetric matrix for this quadratic form is 1, 1, 3 over 2, 1, 4, a half, 3 over 2, and then a half, and then 6, which is the same result we got in the previous case. So similarly, if we have this problem that express this problem 2, express the quadratic form x1 squared plus 2 x2 squared plus 2 x3 squared minus 2x1 x2 minus 2x2 x3 as a product of matrices. So remember, trivially, we should know that quadratic form x1, x2, x3 is of the form x prime a times x, where we expect this one to be a symmetric matrix. So when you have this kind of quadratic form, to know the correct symmetric form of A, just write x1, x2, x3, x1, x2, x3, and here is x1 squared, x1, x2, x1, x3, x2, x1, x2 squared, x2, x3, x3, x1, x3, x2, x3 squared. And the quadratic form is x1 squared plus 2x2 squared plus 2x3 squared minus 2x1 x2 minus 2x2 x3. So let's see how you fill in the numbers. The easiest place to fill is the diagonal, because coefficient of x1 is 1, so you write 1. x2 squared is 1, x3 squared is 2. So those are the first numbers to fill. When it comes to this, x1, x2, so this position, x1, x2, and the product x2, x1 is the same. So therefore, the coefficient of x1, x2, you divide it by 2 and write one number here, another number here. So minus 2 divided by 2 is minus 1. So this will be minus 1. This position will be minus 1. And x2, x3, with reference to this, is negative 2. So negative 2 divided by 2 is negative 1. So this will be -1, this will be -1. And because in the quadratic form given, there is no x1, x3, so it's as good as we had 0, x1, x3. So 0 divided by 2 is 0, 0 divided by 2 is 0. So therefore, the A matrix or symmetric matrix for this quadratic form is 1, -1, 0, -1, 1, -1, 0, -1, 2. So that is the symmetric matrix for that quadratic form. So which means the quadratic form in matrix form given by x prime a x will be given by x1, x2, x3, times the symmetric matrix A given by 1, -1, 0, -1, 1, -1, 0, -1, 2, and then times the x vector x1, x2, x3. So that will be the final solution to that given problem. Thank you.